it is incredibly hard just to allow the possibility that it's a mystery and not to feel the urge to get the answer. It is incredibly hard, but it's possible, and it is liberating as a recovering addict to knowledge. Let me say what you gain from it. For instance, I understand the value of paradoxes. I appreciate paradoxes more. And, to use another philosopher, Søren Kierkegaard, the Danish philosopher, said, a thinker without paradox is like a lover without passion. A paltry mediocrity.
Ooh, that's a good line.
All right? So, and Niels Bohr said, in similar vein, the great Danish also. Something about something about Danes. I think it all started with Hamlet, He said, the opposite of a simple truth is a falsity. But the opposite of a great truth is another great truth. In other words, things are not black and white, they're not. And I would even venture to say the most interesting things in life are like that. They're the ones which are ambiguous. Is an electron a particle or a wave? It depends how you set up an experiment. It will reveal itself as this or that, depending on how you set up an experiment. This bottle, if you project it down onto the table, you will see more or less a square. If you project it onto a wall, you will see a different shape. A naive question would be, is it this or that? Because we understand that it's neither. But both projections reveal something. They reveal different sides of it. A paradox is like that. It's only paradoxical if we are confined in a particular vision, if we are wedded to a particular point of view. It's a harbinger, if you will, of a possibility of seeing things in a more as they are, as a more sophisticated than we thought before. You see,
that's such a difficult idea for science to grapple with. That I don't know how. There's so many ways to describe this, but you could say maybe that the subjective experience of the world from an observer is actually fundamental.
But we know that our best physical theories tell us that unambiguously. In quantum mechanics, actually, Heisenberg, I think, captured it the best when he said, what we observe is not reality itself, but reality subjected to our method of questioning. When I talk about electrons, for instance, so that there is a very specific way in which this is realized. There is a so-called double slit experiment, right? So for those who don't know, it's you have a screen and you have an emitter from which you kind of shoot electrons, and in between you put another screen which has two vertical slits parallel to each other. If we were shooting, tennis balls, each ball would go through one slit or another and then hit the screen behind this or that slit. So you would have, and let's say they're colored, they're painted. So there will be sort of bumps or spots of paint behind this or that. But that's not what happens when we shoot electrons. We see an interference pattern, as if we were actually sending a wave, so that each electron, it seems like each electron goes through both slits at once, and then has the audacity to interfere with itself, where at some points, two crests would amplify, and at some points a crest and a trough would cancel each other. Yet, so that suggests, okay, so the electron is a wave, not so fast, because if you put a detector behind one of the slits and you say, I'm going to capture you, I'm going to find out which slit you went through, the pattern will change and it will look like they're particles. So that's a very concrete realization of the idea that depending on how we set up an experiment, we will see different results. And the problem is that our psyche, I feel, kind of is lagging behind, in part because maybe our scientists are not doing such a great job. So I take responsibility for this, that why haven't I explained this properly, I tried, in a bunch of talks and so on. So now I'm talking about this again. Our psyche kind of is lagging behind. We're still, even though our science has progressed so much from the certainty and the determinism and all of that of the 19th century, our psyche is somehow still attached to those ideas. The ideas of causality or this naive determinism that the world is a bunch of billiard balls hitting each other, driven by some blind forces. That's not at all like it is. And we've known this for about 100 years at least,
And you call this self-imposed limitation.
It is a self-imposed limitation when we pretend that, for instance, that this naive ideas of 19th century physics are still valid, and then start applying them to our lives, and then also derive conclusions from it. And for instance, people say there is no free will. Why? Oh, because the world is just a bunch of billiard balls. So where is the free will? But excuse me, didn't you get the memo that this has been debunked thoroughly by the so-called quantum mechanics, which is our best scientific theory? This is not some kind of bullshit or some kind of concoction of a madman. This is our scientific theory, which has been confirmed by experiment. So we should pay attention to that. But of course, it's not just self-imposed limitation. Unfortunately, in this case, there is a big issue of education. So a lot of people are not aware of it through no fault of their own, because they were never properly taught that. Because our system is broken, education system is broken, especially in math. And then so where do you get information? You get information from our scientists who actually write popular books and so on, which is a great, great thing that they do. But a lot of scientists somehow, when it comes to explaining the laws of physics, they're doing a fantastic job talking about this phenomenon, for instance, double slit experiment and things like that. But then, interviewed by a science magazine about free will and so on, they revert back to 19th century physics as if those developments actually never happened. So to me, this is the single most important sort of issue in our popular science. The idea that somehow there is this world out there, but it's has nothing to do with me. Mm-hmm. So I can revel in the intricacies of these particles and their interactions, but completely ignore what implications this has for my own relationship to physical reality, to my own life, because it's kind of scary, I guess,
But also, what are the tools with which we can talk about the observer, the subjective view on reality? What are the tools with which we could rigorously talk about free will and consciousness? What are the tools of mathematics that allow that? I don't think we have those tools.
Because we haven't been taught properly. So actually tools are there. For instance, I think, here I have to say, my conviction is that everybody knows. In the heart of hearts, everybody knows that there is that. There is something ineffable. There is something mysterious. And in fact, somehow immediately I feel the impulse to quote somebody on this, because as if my own opinion doesn't count.
Yeah. There's a long dead expert that has
even
said it.
Einstein said that, so like, how, see, look at me. I am supposedly like this smart, intelligent person. Yeah. I am afraid to say it and own it myself. I have to find confirmation. I have to find an authority who agrees with me. And in fact, it's not so difficult to find, because Albert Einstein literally said the most important thing in life is the mysterious. Okay, he actually said that. There are some quotes which are attributed to him, which he never said, but this he did. I investigated. Okay, so but more importantly, how do you feel about it? I think that everybody knows, but in other words, he also said, Einstein, imagination is more important than knowledge. Okay, and he explained, for knowledge is always limited, whereas imagination embraces the entire world, giving birth to evolution. It is, strictly speaking, a real factor in scientific research, he says. And he says, I am enough of an artist to follow my intuition and imagination. That's Albert Einstein, again. So, and I feel the same way, to be honest. If I think about my own mathematical research, it's never linear. It's never like, give me more data, give me more data, give me more data. Boom, the glass is full, and then I come up with a discovery. No, it always felt as a jump, as a leap.